So Barb, you and I have both been fascinated by the power of Tinbergen's 4 questions to get us to be more systematic about trying to explain biological phenomena, especially disease. How did we share this? Just tell me how you got into it and how it's helped you.
Right. Well, I first learned about the 4 questions, Tinbergen's 4 questions, when I was at the Evolutionary Medicine Summit.
Is that right?
And now I teach a large undergraduate course at UCLA on evolutionary medicine, and I use the Tinbergen, that frame, those 4 questions, as the frame for the whole course.
So we'll just go through them for people?
Sure. So Tinbergen, of course, was a Dutch biologist and an animal behaviorist who had many contributions to medicine. His contributions were actually recognized in the form of a Nobel Prize in Medicine and Physiology in 1973. But among his contributions was a framing structure that we call Tinbergen's 4 questions. And Tinbergen essentially felt that most explanations of causation, sort of most causal explanations, are very mechanistic. They're very proximate. So if you ask why the rooster crows, the answer would be, oh, because the sun came up and light streamed into his eyes, right? But there are, Tinbergen felt, a more holistic, deeper series of questions that give a better and a broader explanation. And so Tinbergen decided that there were 4 questions, he believed, that had to be applied to any biological phenomena in order to arrive at a holistic understanding of that. And those questions, which I'm going to tell you in one moment, but every one of those questions can be applied to every human or animal medical disorder or disease in order to arrive at a much broader understanding of it. Now, Tinbergen wasn't a physician.
I argue with you a second. I don't think you really mean the disease, you mean the trait that makes you vulnerable to disease generally.
To disease
right?
vulnerability, correct.
Yep.
Yes, to disease vulnerability. Now, Tinbergen was not a physician, and he developed this framework for the study of animal behavior. But it is so valuable in its simplicity and in its breadth that it is highly usable, and I think should be used by physicians to arrive at a much better and deper understanding of why their patients get sick.
And then not alternatives. You need answers to all of them.
You have to deal with all 4.
So let's just go through them.
Right. So if you can think of Tinbergen's 4 questions as being sort of 2 categories. One which asks the question why, and answer them from a very mechanistic or proximate, and one from a kind of a developmental perspective. So I'll give you an example from human medicine. So heart attacks, as I've said, is the leading cause of death among human beings. Now, what happens when you have a heart attack, is basically there's a plaque in the artery of your heart that breaks, and blood oozes into that artery, and that blood clots. It clots off, and now you've got
Sounds like a mechanism.
It's a mechanism. It clots off, and now there's no blood that can pass through that artery, and so that heart muscle that's downstream from that blockage, it starts to die, and you clutch your chest, and that's a heart attack.
It's a mechanic's view. What's the
So
second?
over the course of my life as a cardiologist, I've been in ICUs, CCUs, ERs with patients, and the question is asked, why does this happen? And the typical mechanistic, that is proximate explanation for why this heart attack happened would be exactly what I just said. Right. You had a plaque. That plaque cracked. There was blood that flowed into it, etc.
And I like to add, actually, once it goes, it's a positive feedback process, because once you get a little bit of a clot, it causes more turbulence, which causes more clotting, and the clot just grows.
Okay, so that's still mechanistic. That's true, and it's very mechanistic. Yeah. And it's very much what we do in medicine. We get very reductionistic and more mechanistic in a very narrow way. And what we're doing with Tinbergen is we're doing the opposite. We're trying to see the big picture. It's kind of the elastic recoil
opposite
back
of reductionism.
from, right.
Yeah.
So first we have proximate. The proximate, that is mechanistic explanation would be, the plaque ruptured and a blood clot formed. Right. Now, still somewhat proximate would be a developmental answer, what Tinbergen would say an ontogeny-based explanation. So that would be to say, well, you know what, Mr. Smith, you had a heart attack because this plaque ruptured and this blood clot formed. But also, over the course of the last 4 decades, you have been accumulating atherosclerotic changes in your coronary arteries. They started when you were a teenager. It's partly due to diet, it's partly due to environment, it's partly due to genetics. And we could actually draw a picture of the progression of atherosclerosis, of that plaque that ended up rupturing over the course of your life. That would be a developmental perspective.
So these are both proximate mechanistic.
Those are both on the proximate side.
Let's go on to evolutionary ones.
Now, Tinbergen would say that while we need proximate explanations and we need developmental explanations, a holistic understanding of that heart attack would also require two other components. First, it requires a phylogenetic consideration. That would be a kind of comparative perspective to ask the question, well, does vulnerability to a heart attack, is that really unique to human beings? Are there other mammals? Are there other primates and then non-primate mammals? Are there avian species? Are there reptilian species? Are there piscine species whose coronary arteries are also vulnerable to this disorder? That would be a phylogenetic perspective, and I'm not going to tell you right now why that's so important, but it is.
Right.
And then the final Tinbergian non-proximate, that is evolutionarily informed perspective, is the question of adaptive value. And the question becomes, what is the adaptive value of vulnerability to that heart attack?
Right.
And the answer to that question all of a sudden takes you deeply back into the world of mechanism, but in my mind in a much more fruitful hypothesis-generating way. Right. So for example, we might say, well, what is adaptive about that heart attack? Well, one aspect is that blood that clotted on top of that fractured plaque is full of platelets, which are full of clotting factors that are very effective at hemostasis, emergency hemostasis. And that in an environment, in an ancestral environment where trauma was a real existential threat, certainly more of an existential threat than atherosclerosis, having a robust clotting mechanism is highly adaptive.
Well, I think at some point we need to get a bunch of people together just to talk about Tinbergen's questions. I mean, I've been so fascinated by them, and as I think I've told you, I spent a couple of months in London in 2002 just thinking about this and creating the 4 boxes and putting it on the web. It's so deep, and so many doctors don't get it yet.
Well, I'm writing a textbook chapter right now on the evolution of the heart, and it's based exclusively on the Tinbergen frame.
Great.
And one of the things I do is I look at the top 5 cardiovascular diseases that affect human beings, and I go through
each one. I
have a proximate mechanistic explanation, which is the traditional medical explanation. I offer a developmental explanation. I then offer a comparative, a phylogenetic perspective. I've actually created a phylogeny of disease vulnerability across vertebral species, and then offer adaptive hypotheses that will hopefully help a reader understand the vulnerability in this broader, more holistic context.
It's such a major advance Tinbergen offered to us, and it's such a great example of, it's not like he gathered new data, it's not like he did a lot of experiments, but he sat down and thought very, very clearly and provided something. And amusing, you may know this already, he wrote it to honor his mentor, Conrad Lorenz, because it was Conrad Lorenz's birthday and he was getting old. He was getting to be 60 years old, which doesn't seem that old to me. That's really great.